Alrighty.
All
Howdy,
right,
everyone.
take it away.
Like Professor Hank said, my name is Darren Dunlap, and this is a case study on Mgenesis, the company that I worked for over the summer, and am now transitioning to part-time to work while I finish my Master's of Engineering. So a little bit about me. I was born and raised in Amarillo, Texas, surrounded by agriculture. My family owns a ranch up there in a small town called Pampa, Texas. And from that, I learned that I didn't want to work in agriculture, so I decided to go into tech. I then graduated in 2023, so last May, with my undergrad in biomedical engineering, and I'm now pursuing my MEng. And it's funny enough that I decided I didn't want to do agriculture, and then now I'm working at a tech company that works in agriculture. And then my specialties include software, embedded systems, control systems, and anything else electrical. I thought I liked chemistry at the beginning of my degree, and through the end of it, I realized that that was not my strong suit. So that's why I focused more on the bioinstrumentation side of things. So hopping right in, over the summer, I interned at a startup called Mgenesis, where they are trying to improve the efficiency rates of in vitro fertilization, primarily in cattle, but we are working on a few projects in other animal species as well. This is because right now IVF is currently sitting at a accuracy rate of 50%, and it has stayed there for the past 10 or so years. And so this is primarily due to technicians and vets not knowing how to analyze their embryos. So we're trying to use machine learning and data science to act as a second opinion to hopefully improve these rates. So the reason why there's only a 50% success rate with pregnancies and cattle is because the technician training is the primary way that they grade the embryos. So if the technician wasn't trained very well, they could classify a dead embryo as a grade 1, which is the best grade. And we've seen that multiple times where our vet gets an embryo thinking that it's one of the best ones, and then he goes and looks at it and he's like, this embryo has been dead for a long time. So it's really experience based, and there are some qualifications and standards, but they're not very well taught. And again, it's all visual, just looking through a microscope, no exact math or anything like that. And so because of that, the success rate to pregnancy and a viable calf has stayed around 50% for quite some time. This shows how there are lots of embryos. Again, we get 50% pregnancy rate about, but then 15% of those pregnancies usually end up not going to term, or they have some kind of disability when they're born, or really weird like factors that come into their growth in utero. So we're trying to make it to where the pregnancies occur more often and are more successful. So the data that we use in our machine learning application consists primarily of still images and videos of these embryos in culture. We have about 1,000 videos of, or 1,000 embryos spanned across multiple videos. And we're right now classifying them into pregnant and non-pregnant classifications. And we want to eventually move to more of a detection model where we detect the embryos and detect features within the embryos. And this data was obtained through videos, through microscopes using just your iPhone, which makes it really easy for collecting the data. And right now, our app, you can even use your iPhone and upload your embryos straight from your iPhone, which is good for vets that don't have microphone or don't have microscopes already equipped with cameras. Um, and so what we're trying to do is use Ultralytics, which is a specific machine learning platform, and I'll go more into depth with that later, and use just image classification models to look at the RGB values of the pixels and see if there's any trends in there with a bad embryo and then a good embryo. And then once the user uploads their own embryo, we give them a percentage rate of success. So I kind of already went into this a little bit, but Ultralytics is a machine learning framework that's super lightweight. So eventually, I think Professor Hanks will start to teach you about TensorFlow. That is a more in-depth, robust machine learning framework, but it's really big. So whenever we're using AWS, which is our cloud provider, we have to keep all the app things small. So Ultralytics is very lightweight and very fast, and they utilize the YOLO V8 image classification model. And so all classification does is it looks at an image and it puts it into class A or class B if it's binary. You can also do multiple classifications, which is what we're trying to move to, where we have oocytes or dead embryos, good embryos, middle of the pack embryos. And it just looks at the data in the image and then classifies them using linear regressions and other machine learning models. This is kind of a preview of our app right now. So you first record your video through your microscope of your embryos. Then you upload it to our app, and the app detects where your embryos are at and gives them a score based on if they are viable for pregnancy. So we're just trying to eliminate the time and resources that get wasted whenever you implant an embryo that's not viable, because sometimes the calf may take the embryo to term, or the cow might take the embryo to term, and then the calf isn't viable and you have a stillborn calf. And then other times, it's pretty expensive to do things like this. So we're just trying to eliminate any wasteful spending.
A couple of questions, Darren. What is your goal right now for accuracy? What do you think that will be valuable in the marketplace?
Yeah, so right now, since the accuracy with the gold standard of the vets is 50%, we're trying to hit 75% accuracy. So that way, uh, you know, a 50% increase is pretty good for the industry just as our first product. And then once we fine tune the model better, we want it to be closer to 95. Right now, we're kind of aiming for it to be a second opinion, but eventually we want it to be its standalone. This works every time.
Can you talk a little bit about the features that you're recognizing, or
Yeah.
let me give a little
So I
background on
think,
how that works?
yeah. So one feature, so we have multiple features and multiple data categories, especially in the species of the cattle we've noticed has taken to play. And the biggest feature that we've also noticed that has an impact on pregnancy is the activity of the embryo, which is something you can't see through the microscope because embryos, they move and they're dividing and they're growing, but it's really hard to see that with the naked eye. So that's why we're trying to use machine learning to see if a pixel moves 1 pixel over or something, then the computer can detect that. There are also things in embryos, and I'm not super well knowledgeable on these things, but this is a good embryo over here. And as you can see, it's really uniform and it's really taken up the whole embryo. And this is turned into a blastocyst, while these ones over here, you can see the cells inside are kind of clumpy and they're not regularly distributed. So we noticed features like uniformity and things like that have also taken a play. And then other features just include the sex of the embryo and the donor as well plays a big key.
Okay, that's really cool. So that's really interesting that you're using video, and probably categorization in the past has only been based on images, right? So
Mm.
that's a really new way of looking at the data.
Yeah, and so there are ways you can do uh kind of like two models in conjunction with each other where we use the videos and the numerical data at the same time.
Okay.
So just a little bit of background on the tools that I used over the summer. If any of y'all want to go into software development or machine learning, please feel free to reach out to me. You might see me in the hallways too, because I'm still a student here, because I can talk about this forever. But this was one of the biggest challenges that I thought wasn't covered in material because it's honestly hard to cover it without learning it in the industry. So the primary tools that we use include GitHub. to store. It's like the Google Drive for code. It just stores all of your code and keeps it up to date. And you can use GitHub to automatically deploy your app every time you make changes. And then we use AWS or Amazon Web Services for all of our cloud computing. So what we do is when you upload a video, it hits AWS, and AWS has hundreds of services, so I can't go into depth on all of them. But the primary ones that we use are Lambda and DynamoDB. And so the Lambda runs the machine learning in the background every time a person uploads their embryo, and then DynamoDB just stores that data. And then if you want to go into web development, I could also talk about Flask, which is a Python framework to run the back end of your applications. And then we also just use Python. That's like our main tool. Whenever I was going into software development as an internship, I thought that Python was more on the data science side of things and less on the web development. I thought I was going to be doing a lot of C and JavaScript, but it turns out Python is really growing in that realm. So don't be afraid to just really get into nitty gritty with Python, and don't feel like you have to learn other languages as of right now. And plus, if you're good at Python, you can kind of transfer that over to other languages pretty easily. So now that I've talked about mGenesis, are there any questions or anything like that before I go into the challenges? I kind of sped through that pretty quickly, so if you have anything, speak up.
I do have a quick question. When you were talking about taking pictures of the embryos, did you mean like the microscope takes a picture and then you take a picture with your phone of the microscope's picture?
So right now we have our vets literally just putting the camera of your iPhone up to the eyepiece of the microscope. We found that the iPhone camera actually works the best because some cameras do, or some microscopes do have cameras, but they don't work very well. So it's just literally putting the camera up to the eyepiece of the microscope, if that makes sense.
Okay, thank you.
Yeah. And then going on that a little bit, we do want to eventually have some hardware that we sell as part of our app that standardizes it, because we've noticed, the lighting in different offices is different and everybody has a different quality iPhone camera and things like that. Any more questions? All righty. So one thing you'll learn once you start working is that school gives you the knowledge that you need to be successful, but they don't always tell you about the skills that you need that aren't just the cold hard facts of, whatever you're trying to specialize in. So I experienced many challenges at the very beginning of my internship, and it was a very steep learning curve, but I got through it, and so will you. And so I'll go into depth about all of these topics right here. So the first one in software development is most teams these days use agile development, and it's kind of a heated topic of debate right now because some people use it too well. But in essence, your project is split up into sprints, and these sprints are 1 to 4 weeks. In Genesis and Vitality Robotics, we use 2 weeks to be standard. And what you do is at the beginning of your sprint, you create a backlog of tasks that you say, oh, I'm going to get these things done to the app in these 2 weeks. And then every day you have a daily stand up and you talk about what you did yesterday, what you're going to do today, and then anything that's preventing you from being successful, or what are known as blockers. And then you kind of work together, but you're also pretty individual. And then at the end of the sprint, once everything is finished, you have a sprint planning meeting for the next sprint, and it kind of just keeps cycling like that. And this way it keeps you on task, and it also allows you to be agile. So if you need to bring in tickets, like say there's a big bug, then you need to move that in because it's of higher urgency. And it is a heated topic though, because some managers use their daily stand-ups too much and you're in meetings a lot. So a lot of people are trying to find a new way. So by the time y'all get into software, it might be a little bit different because people are starting to not like Agile just due to the amount of meetings that you're in.
Couple of words on Agile. So all of the companies I've worked with, we use Agile development, and
Oh,
the
really?
sprints can be anywhere from one day. What Darren's talking about now is you nearly meet too much to a week. And actually, in our project development, I use Agile development. So I give you a milestone, a spreadsheet. I have you list out the risk and then any blockers. So very similar to what Darren talked about there, but it's just a small amount of Agile. You only have 2 milestones or 3 milestones this semester. So trying to
Yeah.
introduce you to this concept. So
Yeah, just I really like Agile. Just make sure if wherever you get a job, they don't do too many meetings because you want to work, you want to get stuff done. The other thing that I learned in software development is a topic called CI/CD, or continuous integration, continuous deployment. So when you're learning Python in school, you write your code, you run it, you see if it works. If it doesn't, you debug and you kind of repeat that cycle. But one thing that you have to do on an industry side of things is have lots of blockers put in place every time you update your code, because you have an app that users are using that you don't want to take down. And I actually did that once, and that was pretty stressful. So continuous integration refers to developing tests for your code to make sure that your code works. And then once those pass, hence the green check mark right here, then you deploy to however your deployments work. So that was another thing that I had to get used to. We use GitHub Actions, and they're pretty complicated. So just know when you get there that a lot of your work is going to be spent on this pipeline and not on your actual code. Another challenge that I had to overcome, and Professor Hanks will teach you this, is that machine learning and Python have become the easy portion of machine learning. Nowadays, there are many packages, like I said, TensorFlow, PyTorch, Ultralytics, that allow for the creation of a machine learning model with only a few lines of code. So the hard part now is getting data. And you can't just get a lot of data. You need good data, and you also need a balanced data set. So it's important that you know that if you become a machine learning engineer, coding is a small portion of it. The hard part is getting the data and making it fit to your application. Unit tests, these go to the continuous integration pipeline that I was talking about earlier. A lot of my coding is actually just writing these tests for the things that I add to the app. So every time I add a feature to the app, I have to write tests to make sure that my code for that feature are working with the rest of the application. Nowadays, you can use ChatGPT pretty well to get these unit tests done because they are time consuming and pretty tedious most of the time. They're pretty repetitive, but they are very important to making sure that when you push new code to GitHub, the app is still live for your users. And the biggest challenge I probably had was prioritization. There's always work to be done, and there's always a million tasks that need to be completed. So especially at a startup, like Professor Hanks likes to say, 2 years at a startup is like 10 years really of experience. So there's always a lot to do, and you have to really learn how to prioritize your work. And, you guys have to do this with your homework right now. And I like to follow this matrix where if it's urgent and important, then you want to schedule it or do it now. And then, if it's not so important, then you can drop it or delegate it. Or if it's not so urgent, you can line it up in the next sprint. So that's what we really had to learn. I was always really excited to start working on the machine learning part of the app, but we had some few back end and front end bugs at the beginning of my internship. And I always tried to ask my boss if I could work on the machine learning, and he was like, no, because bugs are very important and very urgent. So we have to get those squashed before we add new things to the app. So just know that prioritization is a very important skill that allows you to be pretty successful in the work field. So overall, lessons learned in industry, what you might consider actual work, programming, engineering, experiments, whatever you guys decide to go into doing, is a small portion of the job requirements. Documentation is key. I thought that I was getting away from documentation by going into software, so I didn't have to deal with the FDA, but you still have to document everywhere that you work. So make sure that you stay ahead on top of that. And if you didn't document it, then you didn't do it. Planning is another huge part. The teams that often just jump right in usually end up getting it done slower than the teams who spent 80% of the time planning and 20% of the time executing. And industry is very cyclical. You get an app out there, oh, users don't like this feature, so then you have to bring it back and reevaluate and go back, and it's a big long cycle of always adding new features, changing features, things like that. Another thing that I learned was utilizing best practices. So in the software world, there's a lot of best practices that are adopted by many people. My favorite one was the rubber duck method. So I have my rubber duck that my sister got me for graduating. And instead of having to ping my boss on Slack all the time, if I walk through with the duck my code, it often shows and highlights where I went wrong. So there are lots of cool tricks like this to help work go smoother. Flowcharts are huge in software and probably everywhere. So learn how to make flowcharts. Those really help keep you organized, and especially in complicated solutions, flowcharts help you understand where you're at in the process. And again, documentation. If you didn't document it, you didn't do it. And then the biggest thing is ask for help. If you're stuck for a few hours or a day on a task, there's people around you to help you. So don't be afraid to ask for help. And key thing, find a mentor. I kind of did that in Professor Hanks, and he's the one who really helped connect me with Genesis and helped me along this path. So I'm really appreciative of that. And like I said, if you're stuck for more than a few hours, ask for help. So that kind of summarizes everything. I know I went through that pretty quickly, but are there any questions, feedback? If you want to talk about Genesis, we can talk about that. Or if you want to more focus on skills in software engineering, we can talk about that too.
All right, first let's give it for Darren. Give it up for Darren. That was really nice, Darren. That was awesome presentation.
Thank you.
Thank you very much for sharing your experience. I think having somebody speak the way it really is, you're just a few years ahead of the students in this class, and you're speaking from experience the way it really is. So really appreciate it.
Yeah, I appreciate you having me here to talk about my experience.
It's a really nice inspiration. See projects that you're working on, and then also how important all these tools are in industry, right?
Mm-hmm. Yeah, don't be afraid to get your feet dirty immediately. That's kind of what I did, and it ended up working out.
Okay, one last call out for questions. You can put it in chat, or we'll move on with the class. Okay, Darren, you're free to stick around if you want, but if I know you're busy and you got stuff you're working on, so good luck with things, and we'll talk soon.
Alrighty, sounds good. And then anybody real quick, my email right here is like my work email. Feel free to take a picture of that if y'all ever want to email me. I can really help y'all learn things in the software world if that's what you want to do. And again, you might see me in ETB walking around. Don't be afraid to come say hi.
Fantastic.
Hey, I have a quick question for you, Darren.
Yeah.
So I kind of work on coding in like a research lab that I do, but like outside of classes and labs, like especially with machine learning, since like I'm kind of unfamiliar with it, I don't know what to do to like practice it or work on it. So do you have like any advice for things like outside of things I have to do for assignments, or like outside of what people ask me to do for working on things like machine learning and coding, especially when it comes to like having to do it in like the job world?
Yeah, so there's this there's this website called Full Stack Deep Learning. I can drop this link in the chat. This really teaches you how to be an industry machine learning engineer. and go through many of the tools to have like an up and running app. I would also like make projects with AWS, try to get a simple app up and running on AWS where you can go and maybe it's just a picture of yourself. And I would start simple and work through these things. And then for machine learning, you kind of have to come up with an idea that you have. I would recommend image analysis as it's huge in the medical world. And just try to find data sets online. You can go to Kaggle and there's tons of data sets and try to just practice looking at new data and using more machine learning skills that you learn through this course. Make sure that if you do this course, it's free, that you actually practice it and not just like follow it. And that'll put you in a very good spot.
I think that's great advice, Darren. I mean, I really like to say that once you've identified your own problem, not a assignment that a professor is giving to you, then that's when you really start learning, right? It's like, oh, I want to go understand how to build this application, and maybe I can deploy it and have people use it and impact the world or charge for it or something like that. That's when the learning starts, really.
Yes.
Okay, cool.
Okay, thank you so
Well,
much.
Darren, we got a little bit to cover in class today, and we'll send you off with a great 3-day weekend. All right, take care, man.
All righty. I appreciate it, y'all. Y'all have a good weekend.
Okay, take care. All right, that was fantastic. It's great to see our students being successful. That's so cool. It makes me happy. Okay, let me share a few things here. We got a couple of topics in class, and then you guys can have your 3-day weekend. Okay. All right, just a reminder that for the test, I think you can see my screen. Let me double check with you guys. Can I get a thumbs up, please? Yeah. All right, what's going to be on the test? All the reading material that we've assigned in Canvas, all the lecture materials and example code, and the recommended videos, okay? And a reminder that I've said that you can use a 8.5 by 11 piece of paper, two-sided. You bring the paper, the cheat sheet into the exam, and there'll be no use of ChatGPT or Google. Okay, for today, I have a couple of very short topics to cover since I knew that we had a guest speaker. And let me get that up real quick. Okay. We have spent some time talking about the need for trained validation test data sets. And just to really recap that is, why do we need 3 sets? Sometimes this is not clear. Developing a model always involves tuning. And so if you tune, then you might add bias to you might overtrain, overfit your model, okay? So the idea is to reserve a test set and then have a training and validation iteration so that you can make a really good model. And we've used this as kind of to describe it, but there's some more complex ways to do this. And one of them is called K-fold training and cross-validation. So the way you do this is you set up a training set, and then you set up a test set, and then you come up with these partitions of the data. So in this case, we have 5 partitions or folds. That's what the term fold, right, comes from. And we reserve or hold out the test set, we train, and then we have some error that's associated with that. And we do that across all of the folds or partitions, and then we average the error. I like using this technique, especially if there is a low amount of data. We don't have enough data because, for our heart disease application, we had 300 samples, which is a pretty good data size. And we could easily set aside 20 or 30% of the data. 20% of the data times 300 is about 60 samples. That's a pretty good test set. Okay, so that's important. So when you don't have a lot of data sets, you might need to use a technique like this and then average the error across the fold. And then there's another technique called Monte Carlo cross-validation, where you randomly select on each iteration. You have more folds, and really has the same kind of result. But in this case, you may actually do this a number of times, and there may be a fold that is never selected in your training or in your test. It has some implications for if you're using Monte Carlo. Kind of the difference here is that K-fold, you know, each data set is going to be tested exactly once. And then the data set for Monte Carlo is arbitrary, and it could be even 0 that it's tested, right? The bottom line is the K-fold results in unbiased but higher variance, right? You may have a lot of what we've talked about before in your model, variance in your model, where you're fitting that data, maybe even overfitting, and then Monte Carlo may result in higher bias. Okay, so that's kind of the net result from that. But there are other techniques out there for both doing validation and ultimate test. All right, the other conceptual thing I wanted to introduce to you is this idea of a confidence interval. When I do my applications for grants and when I'm going for FDA approval, I always include confidence interval around the accuracy. And the high level point here is that the confidence interval is tighter for a larger number of samples. So the confidence interval is a function of the number of samples. So if you're looking to get a 95% confidence interval, which is 2 standard deviations, you have to have a lot of samples, or a lot of samples to get a very tight confidence interval. The challenge here is that the equations are a function of the classification technique that you've used. So what I've copied here is a lower and upper bound calculation for the confidence interval based on a binary classification. So I'm not going to have us kind of go into details about all the different ways that we can calculate the confidence interval, but the point here is to know that it is important. And if we take a look at the data that we worked on, we had n equal 297. We had accuracy of 91.6%, and this was for our logistics algorithm. And then if you plug in the numbers, we can calculate that the confidence interval was in the range of 87.8 to 94.3, which is about, what is that? 2.7%. And that's because we had a high number of samples. If we reduce the samples, then this confidence interval would be greater. Those are the high level points. Okay. The other thing I wanted to share today was this idea that we have created a pre-processing checklist. We did a lot of these things in the heart disease example that is due this evening. We did some exploratory data analysis so we understand the distribution, range, and general terms of the data. We identified our different data types: categorical, nominal, categorical, ordinal, numerical data. We will talk about this idea if your data is unbalanced or imbalanced, we can use tools to actually create more targets, more target classes, and more Y variables. And SMOTE is a synthetic way to do that, and it's called augmentation. We'll have whole lectures on that topic. So we didn't really do this, but we looked at to see if our target variable was balanced or not. Then we went through a data cleaning phase, where do we have missing data? Do I impute, meaning do I calculate the mean, the median, or do I remove? We chose to remove because we had lots of data. We didn't check for duplicates. There is actually one duplicate entry in this data set. Probably in the future we'll add that. Duplicate data set does not add any value to our model. This makes the computation more compute time. So we could have removed that one duplicate. And I usually look at outliers. And a big thing in real data collection is sometimes when you collect the data collector, so the method may have resulted in bad data. And you can try to identify, was that outlier because the data was collected properly, or was it the data collected improperly? You can justify removing it if it was the data was not collected in a standard way. Okay. Then we did all these data transformations. We did not, for our heart disease data, do standardization or normalization. some students, maybe in this class or another section, did that. It didn't make an impact on our results of 91.6% accuracy, mostly because standardization is particularly important if you have features that have a couple order of magnitude of difference in their scale. So they're going up to 10,000. One feature has a range of 0 to 10,000, and another feature has a range of 0 to 1, for example. So standardization takes care of that problem. We did talk a lot about ordinal and nominal data and how to transform that. We didn't talk yet about feature engineering, which is a way to, if you know that there are particular features in your data, how do you make them more apparent to improve the model? How do you use data processing, image processing, signal processing to extract more features from the data that you have? And then we did talk a lot about data splitting, the need for validation, train, test, split, and then the use of correlation to see what features could be removed or combined. If all of them are collinear, meaning everything is correlated together, you have a lot of redundancy in your model, and could those features be removed, plus computational overhead, or does it help you identify features that you definitely want to use in your model? Another important thing to realize in this checklist is versioning. In most of the real world applications I work in, is I keep a version tracking of the data, because I might realize that I have got duplicate data in one set of data, or I move it, I save it off in a new version, or if I have got removed data because of there's missing data. So a good versioning scheme to ensure that you're working on the data. If you come back and look at the data 6 months from now, you'll have a good description of that. Okay, so that's our pre-processing checklist. We might add to this, but this is pretty inclusive list of what we need to do for pre-processing. Pretty much a review. The next new topic that I wanted to talk about is something called baseline statistics for your model. If I was to ask you for the heart disease problem, if we just randomly guessed at what the outcome would be for a patient, we would have some probability of success. And so for the heart disease application, we had 160 patients that had no heart disease and 140. So we could look at that and say, well, just by a randomly guessing, we might be, if we guessed 0, that there was no heart disease, we would be correct 160 times out of 300, which is, what is that? It's about 50%, a little more than 50%. So definitely, if we're creating a model, then we want our model to perform better than this baseline accuracy of 55% or so, right? So I'll have you guys talk about that in your projects as one of the things that you describe in your data set. Is like, if I was to randomly make a guess, I would be right 55% of the time in this application. We need to create a model better than that. Okay, moving right along. And then just to review, we've done supervised learning, which really means that we have defined what the target variables are. And then in unsupervised learning, the system figures out what are the targets and what are the features for those targets. So if I had a data set of dogs and cats, and I use that data set on an unsupervised learning technique, it would automatically identify that there's 2 classes, 2 Y targets in the database. But in supervised learning, we basically say, oh, there are 2 targets. Here's the training set on how to train. And we direct the learning of the machine learning system. So that's the difference between supervised and unsupervised. We have not looked at any unsupervised techniques yet. So a technique that I wanted to expose you to today that is a supervised learning technique, just like logistics regression, is called K-nearest neighbor. And it may be one of the simplest and first models that I'll run on data to see if there is any promise in creating a model for an application. So it has a lot of advantages. We'll talk about that in just a little second. But conceptually, how it works is if I have all of these different classes or targets, right? I keep using that term. You guys should know what a Y value is, a target or a class or a category. Those are all terms that mean the same things. So I have all of these, I have these 10 categories in these different colors, and I get a new sample that is green, which is the big color here. If I know the distance between all the other values, all of the other targets here, then I can calculate the distance and say that the nearest neighbor is a green, so I'm going to classify this as a green. So that is K. If I just look at the nearest neighbor, the one nearest one, which is this small green one here, then that's a K equal 1 nearest neighbor. It can get more complex for sure, right? So if I have something a little bit more interesting that's kind of in the middle of all of these samples, if I have a K equal 11, and I do the distance calculation, you may remember from algebra in 8th or 9th grade where you did distance calculations on an XY graph. If you were to draw out the equation, write out the equation, it's x2 for the x value for this, call that x2, minus x1 squared, which makes one part of the triangle. If we were to draw a triangle, and we were to do the same thing for the y value, y2 minus y1 squared, that would give the other side of the triangle. And what we're trying to figure out is the hypotenuse, which is the distance, which is the square root of that, right? It's just the Pythagorean theorem to find the distance. But we're doing that for every one of these targets in our database, right? And then we would pick the 11 closest ones and rank them. The 7 nearest neighbors are red. If the next 3 are orange, yes, this color down here, and then we have 1 which is green. So if we had this kind of distribution, we would declare that this is a red sample. Okay. All right, so that's a very simple machine learning application or model algorithm called K-nearest neighbor. All right, let's show how that works in code. You guys know I like to sling code around here, so let's go take a look at how we would do that in code. Okay, let's see. I think I put the code. Uh-oh, I have to restart my kernel. That's fine. But okay, this is I posted this code, and it's a very simple code. It's got the new modules that you need for K-nearest neighbor. And what this does is actually synthetically generate a couple of classes. We split the data, and then like all the other applications, we basically instantiate an object called KNN, and then we can apply the methods fit and then predict to this instantiated object. Okay, we've done that now for linear regression, logistics regression, and now we're doing it for K-nearest neighbor. So the same pattern repeats over and over for all the modeling. Right, let's hope that it finishes here. It looks like it's trying to load all those modules. Now we're going to do the fit. We've got 100% accuracy on this one. That hasn't happened in the past. All right, so I'm generating random data here. So now I got something that's more interesting with a 90% accuracy. And you can see it generated 2 different classes here. And this one right here, this orange dot right here, the K-nearest neighbors are all blue. So it's categorized that one as probably the one that was not accurate. Okay. I used KN neighbors equal to 7 to be able to identify that. Okay. We can also do that with our heart disease application. And I did that. Now the paper, I noticed in the paper that they got 90% for K-nearest neighbor classifier. When I ran this, I didn't get as high of an accuracy as they did in the paper. So let's take a look at this. I don't think I need to rerun it because I have the outputs here. So I did the same thing. I imported the K-nearest neighbor modules that are needed to run the K-nearest neighbor model. And then I split the data into training and test data, initialize the classifier, and I selected K equal 10. And with K equal 10, I got 86.67. Okay, and I used the whole list of features. I didn't do any removing of features, and maybe that would help improve the model if we remove some of the redundant features. But I don't have an explanation of why we're lower than the paper's accuracy. Okay, so that shows kind of the second model here, and the big takeaway here is it's kind of a few thoughts on picking the value for K. Is if you pick K equal 1 or 2, you're going to get a lot of noise. If you pick K really high, you know, the targets that are close to your new target value, then that's not good either, because that will smooth everything out and you'll get the same prediction for everything, right? So I kind of look at the number of features, and my guess is around half of the number of features. That's my rule of thumb. So we had about 17 features, and I tried 8, K equal 8, then 9, then 10, then 11, and then K equal 10 for this data set repeatedly gave me the best accuracy. So that's how I selected K. And it's the only parameter that you have to set in this model. That's kind of cool. It's only one variable or parameter K that you need to set. Okay. All right, and then here was my confusion matrix with the heart disease, 86%. And let's see, what are these? I predicted it to be a 0, and it was really a 1, so those are false negatives. I had a lot of false negatives. Okay, and we can probably change our K value to change this up a little bit, but unlike logistics, where we could force all of these into one and out of one of the false positive or false negative quadrants, we don't have that capability with the K-nearest neighbor. Okay, some advantages. It's a simple method. Not a lot of parameters. We just have the K value. We can also extend it to do more than binary classes. We can do multi-class classification. We had 3 or 4 target variables or Ys or classes. We could use K-nearest neighbor for that. You can add new training data incrementally, which is a really nice thing, and then update your model. So a lot of nice advantages, some limitations. As the data set grows, the algorithm can be really computationally expensive. And if you have a lot of high K value, then there's more computations that are needed. High dimensionality. So meaning that if the performance can degrade as the number of features dimensions increases. And I believe that this is probably what the heart disease article did, is they reduced the dimensionality. Now, we haven't talked about that yet, but there are methods so that we can go from 17 features down to 6 or 7 features. And basically we're collapsing multiple features into lower dimensions and then create a model based on that. Sensitive to outliers and noise, normalization or standardization is often required for K-nearest neighbors. And then you have to understand or choose a K that is best for your training and data set. When to use KNNs? I think it's kind of your I don't know if I like the term baseline model because I like to say baseline is your random statistics, and then, but this could be your first comparative model to understand if modeling is even possible. It's nearly, for me, it's nearly kind of like a way to do exploratory model analysis or data analysis, but using a model. And it's fast, so you can use it in real-time predictions. And what's the definition of real-time? Well, it depends on your application. Real-time for some applications may be a millisecond, and for others may be an hour, right? And if you have imbalanced data, we've talked about balanced data with appropriate distance metrics, weighting schemes, and k-nearest neighbors can handle imbalanced data sometimes. All right, so those are some when to use k-nearest neighbors. All right, I'm right at the end of our time together today. It was great to have a guest speaker that is in the industry learning things right now and to share that with you. I hope you guys got something out of that. And I'll have a couple more guest speakers of different experience levels come in and talk to us this semester. With that, I'll stop and see if there's any questions about the homework assignment. And if there's no questions, you guys are free to leave, and you guys have a great 3-day weekend.
Professor Hanks,
Yes, sir.
I had one question about assignment 1.
Okay.
So one of the requirements for plotting the 3D data using Seaborn is to use like the percent matplotlib qt to show it in a floating graph. I'm doing the assignment on Spider, and that only like that line of code, like the percent matplotlib qt, only works whenever I put it into the console. So what should I submit in order to get points for that if I can't put it in my actual
You
code?
can just put it in, remark it out, comment it out. And
Okay.
in your code, I think if you add an exclamation point before the percent matplotlib, it will run it. Okay.
Okay, I'll try that. But if that doesn't end up working, I'll just put it in as a comment above.
Yeah, just put it in a comment. That's
where it
fine.
should go. Okay. I actually had one more question. Sorry. In the whenever you ran the predictions, and then you put in the values for mean squared error and mean absolute error that we're supposed to find better values for. You hadn't dropped the nan values for that. So is it okay that we drop the nan values
Yes.
whenever we find mean squared error and absolute error?
Yeah, that's fine, Hunter. That's a good catch. Basically, I created a pretty low bar for you being able to create a better mean squared error. And so I just included, you figured out what I did. I just included the data with the missing rows to see what the mean squared error was, and that's what it was. And so if you remove the missing data, the rows with missing data, you get a better MSE automatically.
Okay, I was just making sure that I was doing it right. All right, that's all I have. Thank you so much.
All right, take care.
Yes, I had a question too. I'm doing it on Jupyter, and with the percent matplotlib qt, it's messing with all the other Seaborn scatter plots that happen after. Like if I run all the kernels at once, it's giving an error when I use the percent matplotlib qt. So can I count it out too, or
Yeah, you can comment it out. To get it to go back to inline, you say percent matplotlib space inline, and then so
Okay.
the following, if you do that, then the graphs after that will be inline.
Okay, so I can just say percent matplotlib inline and it'll be fine.
Yeah.
All right, awesome. Thank you.
Okay, take care.
You too.
Hi, Rajshiri, how's it going?
It's going good, Dr. Hanks.
So awesome. So yeah, I experimented around with, I was using the old quiz, and you found that all the features I wanted were in the new quiz. And so I switched over. So that was awesome.
Okay. I'm glad it worked out.
Yeah, so if you come up with some questions, just go ahead and put them in the quiz, and that way we're keeping it all in one location, okay?
Yes, I'll go ahead with that. I'll probably form it by the end of this weekend. And
Yeah,
I'll
no
let you know
worries.
when I'm done.
Yeah, I mean, I was gonna add some this weekend and then on Monday, probably add some, and then I might then have you look at all of the questions, my questions, and make sure that they are clear and not ambiguous, okay?
Okay, sounds good.
Okay, have a great weekend, all right?
Yeah, you too. Bye bye.
Bye.